Now we're going to take a look at the remaining 4 trig graphs. The tangent and cotangent ones are going to go hand in hand, and then same thing, the secant and cosecant ones are going to go hand in hand. But to actually utilize or come up with the pictures of these graphs, we want to look at what these functions are in terms of sine and cosine. So we'll start with the tangent function. And remember, tangent of x is the same exact thing as sine of x over cosine of x. So we know how to evaluate these at those quadrantal angles really well. So if you think about this, we do now have that variable in the denominator. We are going to have issues when that denominator is equal to 0. So in this case, that's going to be when the cosine function is equal to 0. These in turn are going to cause vertical asymptotes. So tangent of x has vertical asymptotes. When cosine of x is equal to 0. So if you think about your unit circle, that's going to happen on the y-axis. And those are those odd multiples of pi over 2. So ultimately, there are a ton of angles where you're going to have vertical asymptotes. So the tangent function is undefined when the angle we're inputting. And I'm going to start over here with positive pi over 2. Then you have 3 pi over 2, which is 270 degrees. You have 5 pi over 2, 7 pi over 2, and it keeps going. But then you also have those negative angles. So if you go down 90 degrees back to 70 degrees, you have negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. And then it keeps going in that direction as well. So again, this is happening at those odd multiples of pi over 2, sorry. So the way we can formally write this is we're taking those odd numbers. So that's represented by, remember, 2n plus 1. 2 times an integer is always even, and then when you add 1, it makes it odd. So it's 2n plus 1 pi over 2. That represents those odd integers. And then this value of n is an integer. This will get you to negative 5, negative 3, negative 1, 1, 3, 5, 7, 9, and so on. Okay? So that's going to be where we have a vertical asymptote, and our function is going to blow off to positive or negative infinity. If we think about when x-intercepts occur, that's going to be when that numerator equals 0. So these occur where sine of x equals 0. Well, that's much easier to deal with because that's just the x-axis. So that's at 0, pi, 2 pi, 3 pi, 4 pi, and so on. And then you also have the negative angles, negative pi, negative 2 pi, and so on. So our intercepts occur at 0, pi, 2 pi, and it keeps going. Negative pi, negative 2 pi, and then it keeps going in that direction as well. So really this is any multiple of pi. So we write that as n times pi, and again, n is just any integer value. So we're going to start by just graphing this normally with no changes at all. We'll graph it over that full interval from 0 to 2 pi, and then we'll also do the negative case as well. Putting in those quadrant angles, we've got pi over 2 pi, 3 pi over 2, 2 pi, and then you have negative of all of those angles. Okay. So if I go ahead and draw my vertical asymptotes first, those occur at these multiples of pi over 2. So I'm going to go ahead, I'm going to change the style of these a little bit, and then I'm going to just copy and paste it. But that is our vertical asymptote, and it occurs at these odd multiples of pi over 2. Oh, I just want to do Then if we consider our intercepts, those occur at 0, pi, 2 pi, negative pi, negative 2 pi, and so on. If you think about your unit circle, we'll start here in quadrant 1. So remember, it's sine divided by cosine. Tangent is positive here. And as your angle gets close to pi over 2, your sine value is close to 1 and your cosine is close to 0. So you're going to get something close to 1 divided by something very, very small. It's going to blow up to infinity. So tangent is positive in quadrant 1, and it will blow upwards to infinity. This angle here, from 0 to negative pi over 2, is really quadrant 4. And in that quadrant, tangent is negative. And so same idea, it's going to blow downwards now to negative infinity. If you look at from pi over 2 to pi, that's quadrant 2. So same thing, your tangent value here is negative. So it's going to come upwards to that x-intercept. And then pi to 3 pi over 2 is quadrant 3, and tangent is positive. So really what ends up happening here is you get the same squiggle shape over and over and over again. My graph goes this way, and then it goes this way. So really now, our tangent function has a different period. It's pi periodic. So from negative pi over 2 to pi, you go through a full graph. Pi over 2 to 3 pi over 2, which is this half of the unit circle, pi periodic. So the tangent function has a different period. So if we were to shift that in any way by looking at, say, something like tangent of 3x, to find your period again, you can figure out where your period starts, where your period ends, by graphing it, say, from 0 to pi, or graphing it from negative pi over 2 to pi over 2. You can find where those shifts happen, but also you just take pi now and divide it by whatever is attached on the inside. To graph the cotangent function, it's similar because now we just have the flip. Cotangent is defined by cosine of x over sine of x. So really the vertical asymptotes and intercepts end up switching positions. So now here the cotangent function's undefined when sine of x is 0. And that occurs at all of these multiples of pi. And then the cotangent function has x-intercepts now when cosine is equal to 0. And that happens at those odd multiples of pi over 2. Okay. So going through and graphing this one, putting all our quadrant angles. I'm going to steal my vertical line from here. Our asymptotes now occur at the multiples of pi, so that'd be 0, pi, 2 pi, negative pi, and negative 2 pi. Okay. Our intercepts are at the pi over 2 angles. And then be careful you don't fall into a trap. You don't end up actually with the same shape. So if you think now about quadrant 1, that's from 0 to pi over 2. Because of the way cotangent is defined in this part, we have cosine divided by sine. So around here, your cosine is 1, your sine is 0. So if I'm a little bit off of that, my cosine is still close to 1, sine is close to 0. That's a huge positive number. So you actually get the flip shape for cotangent. And then you can see it happens over and over and over again. So that is what our graph of cotangent function looks like. It really can be found just from your tangent graph. So what happens is these asymptotes turn into intercepts. The intercepts turn into the vertical asymptotes. And then you really end up flipping the function because you get 1 over tangent. So these values that were in this direction end up flipping upwards. So it kind of comes up like that, actually. Okay, so same idea here. The cotangent function is also going to be pi periodic. Tangent and cotangent are the only ones with a different period. Secant and cosecant are going to have the same period as sine, but this one, because it deals with cosine and sine inside its definition, it ultimately has a different period. Now, in terms of these functions, all of our other trig, there's not really going to be something of an amplitude. You can absolutely put a number out front here, but all it's going to do is make it like a thinner squiggle. The amplitude specifically defined for the sine and cosine function because it stretches that range out. Here, your range is all real numbers, so it's not going to do anything. If you need to graph over one period, well, really, you just need to find where 2 asymptotes occur and then graph in between those. Or you can find 2 intercepts and graph in between those. The asymptotes just tend to be a little bit easier because you have 1 squiggle. If you found 2 intercepts, you would have to figure out which direction or which half of the graph you have, okay? So let's try an example. Let's graph y equals tangent of 2x minus pi over 4 over at least one period. We'll go ahead and we'll find the period for this too, and we'll find all of those key pieces. So again, you can always break this down into its sine and cosine function to help things make sense. This is sine of 2x minus pi over 4 divided by cosine of 2x minus pi over 4. Okay. I want to graph between 2 consecutive vertical asymptotes. So the vertical asymptotes are going to occur when this cosine function is equal to 0, okay? So again, just pick 2 consecutive values that happens for. You can do pi over 2 and 3 pi over 2. I'm going to go ahead and instead do negative pi over 2 and then positive pi over 2. Because again, thinking of your unit circle to draw you in a solid picture here, this would be negative pi over 2 down here, and then coming up to your next important angle where there's an asymptote is at pi over 2. So I need to figure out what x value this occurs for, so I need to go ahead and solve for x. So we go ahead and we add pi over 4 to the other side. Oops, messed that up. Negative pi over 2 plus pi over 4. Now to get this with the same denominator, again, multiply by 2 over 2. So that's the same thing as 2 over 4. So adding that gives you negative pi over 4. Okay. Well, that's 2x. So really this is saying 2x is equal to negative pi over 4. Dividing by 2 tells us our first asymptote occurs at negative pi over 8. For this one, now we add pi over 4 again. again, got to make this with a common denominator, so that is 2 pi over 4. So 2x is equal to 3 pi over 4, and dividing by 2 gives us our next key value at 3 pi over 8. Okay. So if you need the length of the period, remember it's just the difference in these two, because that's where the vertical asymptote starts, and that's immediately your next asymptote. So your period is just the difference between these two values. 3 pi over 8 minus negative pi over 8, which turns into plus, so that is 4 pi over 8, which is the same thing as pi over 2. Okay? So that is our period. But again, you can find that just from back up here. Really, the formula we have for this is you now take pi and divide it by b when you're graphing tangent of bx plus c. Okay? So for sine and cosine, we took 2 pi and divided it by what was attached to x. Here, because it's pi periodic, you do pi divided by x. Now I also want to figure out what my intercept is between those, and that's the reason I picked this specific one. Your intercept is going to occur at 0. That's the angle between these where the cosine function, where the sine function is equal to 0. So the x-intercepts occur when that numerator is equal to 0 and the angle that happens for between the two vertical asymptotes is exactly here at 0. So it occurs when the inside equals 0. So solving for x, we go ahead and add pi over 4 over, dividing by 2 gives us pi over 8. Okay. So I have everything I need now to get a picture over one period. My first key number is negative pi over 8. And so just to give you some idea, if this is negative pi over 4, negative pi over 8 would be here. This is 0, positive pi over 8, positive pi over 4, which is 2 pi over 8, and then positive 3 pi over 8. Okay. So starting with the asymptotes, the first one is at negative pi over 8. The second one is at 3 pi over 8. And then again, our asymptotes, we like to be dashed or dotted, whatever you'd prefer. So we're going to go ahead and change those to dotted lines. Our tangent function has a 0 halfway in between these two asymptotes. And then I don't have a reflection or anything out here, so I don't have to worry about it. We have our normal tangent graph. So it just looks like this. Okay. And then you could copy and paste this over more intervals if you need to, but it is pi periodic, so we just need it between two asymptotes. Okay. All right. So your cotangent function would follow the same. Again, if you ended up changing this problem slightly and you put that minus sign out front, you would still graph tangent and then you would just have to reflect it. So it would go in this direction and it would look just like a cotangent function instead. Okay. All right. So those are our tangent and cotangent functions. We're now going to move on to the graph of secant and cosecant. But in order to do that, really, you're just going to sketch the corresponding cosine or sine function. And then you utilize that to get your graph of secant or cosecant. So in the same idea though, let's start by figuring out where these things are undefined and where they have intercepts. If you think about secant of x, That is 1 over cosine of x. And same thing as the tangent function, this is going to have vertical asymptotes when that denominator is equal to 0. And that's going to happen at those odd multiples of pi over 2. If you want to try to find x-intercepts, that would be where the numerator equals 0, but that can never happen. So really there is nothing I could plug in for x that will make this fraction equal 0. So there is no x-intercepts. And remember, if you go back a little while ago, we did go over what the range of the secant function is. It's from negative infinity to negative 1, and then also from 1 to infinity. It doesn't hit anything in between, okay? So again, I'm going to start by sketching in our cosine function, and then we're going to utilize that to graph secant. So we still have to go from 0 to 2 pi for cosine, and then let's also do the negative case of each of these. If we graph our cosine function, cosine starts at 1, then goes to 0, negative 1, 0, 1. And then we'll graph that as a dotted line. And then we'll do the back case, but you're really going to copy and paste. Negative pi is negative 1, 0, 0, and then it's peak up here. So also graphing that in as a dotted line gives us this graph. Smaller. Okay. So we now are going to utilize this to get our graph of secant, because I'm going to take the output of the cosine function and that goes in my denominator. So if you think about here, cosine of pi over 2 is 0, so secant would be 1 over 0 here. So this x-intercept actually turns into a vertical asymptote. Okay. And then likewise, 3 pi over 2, exact same thing happens. Cosine of 3 pi over 2 is 0, so when you go to find the reciprocal of that, 1 divided by 0 is undefined. So really, all of these points where I have x-intercepts for cosine turn into vertical asymptotes for the secant function. At these peaks, we can actually evaluate this. Cosine of 0 is 1. So to plug that into secant, that's 1 divided by 1 gives you 1. So you actually have exactly the same output here. Cosine of pi is negative 1. So secant of pi is 1 over cosine of pi. It's 1 over negative 1, which is still negative 1. So exact same thing here at this peak. And really, same thing at all of the peaks. Those are not going to change when you find the flip of them, okay? What ends up happening here is you have a decimal between 0 and 1. So if you think cosine is really close to 0 here, so when you put that in the denominator, it's going to flip and become a really big positive value. So ultimately, your graph is going to come up and hug the vertical asymptote here. Same thing, all of these numbers go in the denominator. So 1 divided by that will turn very large. So ultimately, once you have these peaks, your secant function is just found by flipping them around. So our graph of the secant function turns into a bunch of kind of mini parabolas. Okay, so here your x-intercepts become vertical asymptotes. And this is still 2 pi periodic. So our secant function just looks a little bit funky. But again, same thing, it is going to repeat itself over that interval of 0 to 2 pi. You do need to go through everything. Okay. To graph cosecant, same exact thing. You're just dealing with the sine function now. So y equals cosecant of x is 1 over sine of x. This is undefined when sine of x is equal to 0. So that happens at all of those multiples of pi. Okay? And just like, oh, this is a cosecant function, forgot to change that. Just like the secant function, the cosecant function has no x-intercepts because there is no way that this fraction can equal 0. Okay? All right, so again, we'll graph our sine function over the interval from 0 to 2 pi, and then also to negative 2 pi. And so if we start with our sine function, that starts at 0, up to 1, 0, down to 1, 0. And then we get that S shape. Then it just repeats 0, 1, 0, negative 1, back to 0. Okay. So all of these intercepts end up turning into asymptotes. So our first asymptote is right here. Next asymptote is here because 1 divided by sine of pi is 1 over 0. That is undefined. Next asymptote here. Next one back here. And then one more for this graph that I've drawn. And then same idea, the peaks are going to stay exactly the same because cosecant of pi over 2 is 1 over pi over 2. Sine of pi over 2 is 1, so 1 over 1 still gives you 1. So all of these peaks stay the same. And then you're going to take the reciprocal, so you do 1 divided by it. So your graph ends up flipping instead. So our x-intercepts still become vertical asymptotes. And this is still 2 pi periodic. So only the tangent functions have a different period, okay? So I'm gonna make this as complicated as I can. We're gonna graph a really nasty one that has everything. We'll find all of those key components. Again, we don't really have an amplitude here. It is just the sine and cosine we're gonna be concerned for. So let's go ahead and graph y equals 4 secant of 2x minus pi plus 1 over 1 period. So again, you're always going to start by graphing that base sine or cosine function. Here, because we're dealing with secant, we're going to start by graphing y equals 4 cosine of 2x minus pi. I'm going to completely ignore those vertical shifts because we can take care of those just at the very end. Once I have this graph, then I'm going to use that to graph the actual secant function. So we use that to graph y equals 4 secant of 2x minus pi. Then once I have that graph, remember the very last thing we do, because this is just like addition and subtraction in your order of operations, it's at the end, you take care of it last. Then we go ahead and we're going to shift it up 1 to get the full function we want to graph. Okay. So let's start with the graph of this function. Okay. I again need to figure out, because I've got that phase shift in here, remember it's really going to be this divided by b, but the opposite sign. But again, I like to just full figure that out. Our period is going to start when the inside is equal to 0, and then our period ends when the inside is equal to 2 pi. So that takes us 1 revolution around the unit circle. Solving for x in each of these, we just add pi over. That's 2x equals pi. So x is equal to pi over 2. Adding pi in this case gives us 3 pi. So x is equal to 3 pi over 2. So 1 period is going to be graphed over the interval pi over 2 to 3 pi over 2. The actual period, you can again just take the difference of these two values. 3 pi over 2 minus pi over 2 is 2 pi over 2, which is just pi. But that's the same thing as taking 2 pi and dividing by b. And your amplitude for this particular cosine function is going to be 4. Okay. So we'll utilize all this to get a good graph. Now our graph, though, is trapped between 4 and negative 4. Our first key number is going to be at pi over 2. It's going to end at 3 pi over 2. And then I know there are 3 other key points I need to find within here. And I'll wait to label those, but our cosine function starts at positive, 0, negative, 0, positive. So I'll go ahead and draw this fluidly, but again, I am going to turn this into a dotted line. Okay. So this would be our graph of 4 cosine of 2x minus pi. Our important points would be when those inside equals those quadrantal angles. And really, we just haven't solved for the 3 in the middle. These ones we already have done. This is where the period starts. This is where the period ends. Okay. Getting the ones in between, if you go ahead and add pi, that gives you 2x. Pi plus pi over 2 is 3 pi over 2. Dividing by 2 gives you 3 pi over 4. So this next key number here is going to occur at 3 pi over 4. Let's go ahead and let's actually write it on there, make it a little bit easier. Next key number, if we add pi, that gives you 2x equals 2 pi, dividing by 2. this key number happens at pi. And then here, adding pi gives you 2x equals 5 pi over 2. Dividing by 2 gives you your last key number occurring at 5 pi over 4. Okay. So that is our graph of the cosine function. Now I can utilize that to get my graph of the secant function. You again can do it directly on here, but I do want to show you a clean version without both on it. Put that back in the middle. So we are now trapped between 4 and -4, and I'm going to go ahead and label those same key numbers. Pi over 2, 3 pi over 4, pi, 5 pi over 4, and finally 3 pi over 2. Okay. These points here are those intercepts, so those are going to flip and become my vertical asymptotes. So I have a vertical asymptote here at 3 pi over 4. And let's go ahead and make these dotted. Okay. These points here stay exactly where they are. That one I drew a little bit high, but that's okay. So that point stays, this point stays, and then this point stays. And then your graph is going to flip. So here it's going to flip upwards, here it flips downwards, and then here it flips upwards. So your graph goes up, here it goes down to hug those asymptotes, and then here it flips up. So this would be the graph for secant of 2x minus pi. Now I'm super close at this point, but I do have that vertical shift. So I really need to take this graph and draw it one more time because all of these points have to get shifted up one. So it ultimately ends up changing that range. So let's go ahead, let's zoom out a little bit here. Don't like this bar being in this, so I'm gonna go ahead and move everything down to a clean page to make that nicer to see, okay? So I'm gonna go ahead and actually do full counts, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we still got the same key numbers. My asymptotes do not change because if you shift them up one, it's still a vertical line. So those still occur at the same spots. This point here was at +4, which is right there. So moving it up one turns into that spot. So it starts at 5. And then your graph really stays the same. This point is at -4, which would have been right here, but it needs to move up one. So that value is right here at -3. And then it still keeps that same shape. Okay. And then same thing here, this is at +4, so that has to get moved up one to go through 5. So this would be our graph of 4 secant of 2x minus pi plus 1. You then could go ahead and find the range from this graph. This one's a little bit hard, so I'm going to go ahead and just write that off to the side so you have it. But you take from -infinity up to -3. You can equal that. And then this next interval goes from 5 upwards. So 5 to infinity. Okay. So again, it switched that range. Instead of being from everything except -4 to 4, it got shifted up by 1. Okay. So again, if you can graph your sine and cosine functions, it makes the rest of these graphs much easier. So having a solid knowledge of the unit circle and what sine and cosine are at all of these different quadrantal angles makes a huge impact in you being able to graph these things nicely.